Friends, in today's video, I will tell you how to do the Samsung inverter refrigerator wiring with its diagram. Because often some points are written on the PCB board of this Samsung inverter refrigerator, as I am showing you, let me zoom the camera in. We can understand these. But here we have those things as well we can't understand, that where is its wire coming from and what is its function. If we understand its wiring correctly, we can repair the refrigerator's many faults. Because whenever the wires cut off or burn, we don't understand which wire is it, and which makes it challenging to repair the PCB board or the refrigerator. I will tell you its complete wiring. I will tell you this as well, what is the purpose of all these wiring connections and its working. So let's start the video and let me give you all this information. First of all, I will tell you about its main supply wires, and here you can see these colored wires on these connectors. What is the purpose of these wires, and why they are installed here? So, I will tell you all these things. Now I will explain to you step by step how its wiring is done through its wiring diagram. For that, you will have to observe it carefully and don't skip the video, and if you do so, you will not understand. So, first of all, I will explain to you about its connector numbers 70 and 77, what its connections are, and which wire is installed where. So, see, I have already made the connectors diagram here on the table. This is its connector number 70 I made, which is its upper connector. We have to pass 230 AC voltages on this connector. The blue wire is used for the neutral and the brown for the line. But we have a little twist here. The twist is that the wires near the PCB board have a connector installed, where the wire colors change, blue attached with black, and brown with red. And then, these connections are connected to connector 70. Often, some people don't recognize the color coding wires. That's why I have drawn this figure to make you understand it correctly. Now, when this wire passes through the connector, it has a filtering system here, then gives to connector number 77. But let me make you understand this later in the video. But, first of all, let me tell you about the third wire in connector 70. So observe, this is a brown colored wire, and it goes inside the refrigerator freezer compartment, which is connected with the thermal fuse in the freezer. Then let me explain to you further, you will understand. Then next, it is attached to the heating element. So this third wire is controlled through the PCB board. Rather than that, let me explain to you that I have made a mark here, and I have made it because it indicates that pin 1 starts from this point. So it has 3 pins, and the same way, 4 pins in connector number 77. So always remember this mark. Now, next, let me make you understand that the diagram I made on the table is on the PCB. So it's all printed here on the board, and I am making you understand how it works in the PCB board. This happens in the PCB that a ZNR is installed in it, which is a protection device. After this, a capacitor. And then, a 2 megaohms resistor is used. As if a problem is caused, these things will work to protect the PCB board from spike voltages. A line filter is also used. Now, the neutral has 3 paths here in the PCB. I have already made 2 of them here, so see, one of the neutral is passing through pin 3 of the connector number 77, the next, see, a fuse of 315 ampere is installed here, and the neutral wire through the fuse is going towards the rectification circuit. The neutral is going towards the SMPS of the rectifier to switch on the SMPS circuit, which powers on this PCB board, and to make the microcontroller work. Rather than that, pin 1 of connector 77 is internally connected with pin 2. But the functions of these pins are different. Now, we get another point from the neutral, which is directly connected here, and what is this thing I have already explained to you? I have made a switching relay here, and this switching relay ons the neutral point. Then the thermal fuse and the heating element start working. This way, the defrost system works. Next, let me tell you which wire is installed here. The points I told you before are the printed points on the PCB board. And now I will tell you about connector 77, that the wires installed on this connector, where are the connection made in the PCB board. So see, here in connector 77, the pin 4 is the earthing wire. Then you can see the pin 3, which is brown wire and directly connected to the neutral wire. Means the neutral is converted to the brown wire. This brown wire is then connected to connector CN101, which is installed in the IPM PCB board. So this is the connector with 2 pins in the IPM board, which is the CN101 connector. The brown wire is connected with pin 2 of the CN101. The pin starting from the arrow is pin number 1. And the brown wire is connected with pin 3. Now we have another exciting logic here, that the phase wire coming to connector 77 pin 1 is converted to the pink colored wire. The wire which goes inside the refrigerator body is pink colored wire. But the wire which comes out is red colored, and then this red wire is connected to CN101 with pin 1. Then this orange colored wire goes inside the fridge body, where it is directly installed with the heating element. So it is attached with the heating element's positive side. The negative wired side is controlled with the switching relay to control the on and off of the heating element. After this, the next connector is 102. It has 3 points in it. Let me show you where are they going. So see, they are connected with the compressor as UVW. Blue wire is used as W, purple as V, and black as U, which are connected with compressor. Next, now let's talk about the open wires. But I will not explain it much, as they are open wires and anyone can see it. It is a communication wire installed on the module PCB of connector 201, as you can see it. Same in the power PCB, the communication wire is installed in connector 73, as you can see. Let me zoom in on the camera. This is connector 73, and it is external so that we can check it quickly. A sensor is also installed in the power PCB. It is an NTC sensor with a value of 5.20 kilo ohms at a 25-degree temperature. So you can easily check it as well. This is an external sensor, written on the PCB board and installed in connector 31. Next, let's talk about connector 30. Thermistors are installed here on this connector. Now, let me show you where wires are gone of this connector. So see that the connector 30 pin 1 and 2 is empty. The brown wire is of sensor 1, which is also written on the PCB board if you see it. The brown wire is gone to the electronic thermostat, with its positive supply. Next is sensor 2 installed on pin 4 of connector 30, and red colored wire is used here on this pin. The red wire is the positive supply of the freezer thermistor. Next, the 5th pin is sensor 3, and the wire used for this pin is orange colored. This wire goes inside the refrigerator, and it is the positive supply of the refrigerator thermistor. The next pin has RD written on it with pink colored wire, and some people call it a rotary switch, but it is not a rotary switch as it goes to the electronic thermostat ground power supply. After this, the last pin is gray colored wire. It is the ground of the refrigerator cabinet, but as the sensor 3 I told you is the positive supply, this last pin is its ground supply. One thing is missing here, and I will show that later. Where is it? See, this is its electronic thermostat, which is of this type. And this is called a rotary switch, as it is not a rotary switch, but it is an electronic thermostat. The next connector is 76, installed here on the top. Pin 1 is the ground wire, but it is the ground pin for the freezer thermistor. So the connector I showed you before of the freezer thermistor's ground is not from that connector but this connector 76. If any wire gets cut off here, it will not work as this wire is not common with that wire. After this, next is the black wire grounded with the refrigerator LED light. The 3rd pin is empty. The 4th pin has a yellow wire. The LED light positive 12 volts are gone from the pin 4. The 5th is also empty. The 6th pin connection has a red colored wire which is the positive supply of the fan, installed in the freezer. This power supply controls the fan. After this, the next 2 pins are empty. Next is the 9th and 10th pin. The 9th pin is the feedback of the fan, which tells the PCB at what speed the fan is working. The last pin is the fan's grounding wire. So, this is for today's video. See you in the next one.
I don't really know what comes next, I'm just doing my best even though